Hi, and welcome to the MINEQL tutorial. The problem that we're going to use to demonstrate MINEQL for ECHEM is actually the first problem off of our homework set assigned to MINEQL. The problem is looking at a closed carbonate system. We're using 10 to the minus 2 molar of NaHCO3, and we need to find the pH and the concentration of all the carbonates.
Once you first open MINEQL, you will want to make sure that under the Model tab that you are in the autopilot, which it should be by default whenever you open the program. Once you start at the Select Components screen, you'll have to select the smallest components of whatever is in your system. Since we added sodium carbonate, we need to add carbonic acid and sodium. Water and hydrogen will always be in the system. Once you click everything that is in your system, run Scan Thermo, and this will show you your aqueous species that are in the solution. Click Wizard next, and this is where you add in the concentrations of your components. Since the sodium carbonate was 10 to the minus 2, the sodium will dissociate 1 for 1 and will also be 10 to the minus 2. Be careful to enter this in the right form for MINEQL, which is 1e to the negative 2. The next tab is the pH tab. This is where you can choose to supply the pH or calculate the pH with MINEQL, depending on the problem. Here, if it is going to calculate it, you can enter the total hydrogen, or you can base the pH on electroneutrality. The CO2 tab is where you determine whether it is an open or closed system. For this first problem, we're dealing with a closed system, so we will close it. But if you were to deal with an open system, you would add in the partial pressure of your carbon dioxide there. Or another way when a closed system is to add the total carbonate in the system in the same form that we did the sodium. If you don't know the original concentration, you can estimate it using pH and alkalinity. The next tab is the solids mover. This is where you decide whether you're going to incorporate solids into your system or not. For this first problem, we are going to not consider any solids, so we'll turn them all off. The redox window was not used during environmental chemistry this quarter, so we will not go over that. When you're done with the wizard, click OK, and then, contrary to what you think you may want to do next, close. It will take you to the next window, which is fixed entities. The fixed entities are the things in your solution that have a constant concentration, or a supply if you have a solid that's in the solution. Dissolved solids would include any solids you're considering that are at equilibrium in the system. Once you've closed one more time, you will see the species not considered, which will include the pH, carbon dioxide, and our two solids. Close one final time and say no this time. This is where you will be prompted to give the data a name, such as Demo Problem 1. This will only hold 8 characters, so don't go overboard with your name. Once you click Run, it will take a moment for the data to be extracted, and time depends on the computer you're running it on. Once you get to the Output Manager, this is where you will select whether you want header or special reports or component groups. And the header is the one that shows the original concentrations and K values of everything in the system. This is commonly printed or saved as a text file for the teacher. Component groups is where you can break down the concentrations of a component, and special reports is used very often as a summary of all species for a single run because it contains almost all the data for the whole system. As you can see, it has the components, their complexes that are formed, the fixed entities, your species not considered, and the activity of H+, which will be your pH, and the answer for this first problem. You can save or print any of these files. It is recommended to do so as a text file because it can be imported into Word or into Excel. This is the alkalinity summary, which can also be helpful when doing problems involving alkalinity. One extra special feature is the graph feature. You can make a graph by component to see the different concentrations of their complexes, to see what the dominant ones are and which ones aren't as common. You can see in this system that HCO3- dominates the system and the others are much, much smaller. Once you have printed or saved your files, you are done and you can close the problem to start a new one.
Hi, I'm Jenny and I'm the director.
I'm Robin Stoyles and I was the talent.
Hi, my name is Michelle Brandt and I'm the tech. Thank you for watching our tutorial on MINEQL.